Hi guys, welcome to my channel. In this video we are going to analyze a question is about the structural analysis. The question will be analyzed due to moment distribution method. Let's analyze the question. In this question there is a sideway. By the first assume that we assume that there is no sideway, and then we solve the question with the sideway part. So the frame will be something like that due to our assumption. We will assume that there is a support here, there is a force as R, and there is force here, it's supported, so there is no any sideway, okay? This is the first assumption, the first that we have to solve, the first part. So now let's find the fixed end moment. Fixed end moment from A to D will be equal to WL square over 12. So it will be 0.2 multiplied with 18 square over 12. This is going to be minus, because of the direction of fixed end moment. Positive of this value, because it is the same. And now let's calculate the stiffness factors and then find the distribution factors also. For EI over 18. Stiffness factors DC will be equal to 4 EI over 20. It's going to be equal to 0.2 EI, and stiffness factors for CB will be equal to 4 EI over 12, EI over 3. Okay, and now let's find the distribution factors. Distribution factor AD will be equal to 2 EI over 9. 2 EI over 9 plus 0.2 EI, and will be equal to 10 EI over 19, and distribution factor DC will be equal to 1 minus 10 over 19. Sorry, this is not EI, it's cancelled. Yeah. And 1 minus 10 over 19 is going to be 9 over 19. Let's calculate for CD. It's going to be 0.2 EI over 0.2 plus EI, 0.2 EI. Actually, I don't need to write this one because it's going to be cancelled. 1 over 3, and this is going to be 3 over 8. Okay, 3 over 8, and distribution factor for CB will be equal to 1 minus 3 over 8 equal to 5 over 8. Now I obtained the distribution factors, so let's write its own place. The distribution factors for the first AD will be equal to 0 because it is fixed, the end. So this is going to be 10 over 19, 9 over 19, and this is going to be 3 over 8, so 5 over 8. Now I have distribution factors. Let's write the fixed end moment. 5.4, 5.4, and 0, 0, and 0, 0. So now I have to distribute this moment due to the this ratio. Okay, so this is going to be 0 minus 5.4 multiplied with 0 is going to be 0. 5.4 multiplied with 10 over 19 and take the negative of the value, that will be equal to minus 2.842. Okay, this one will be 5.4 multiplied with 9 over 19, and take the negative of this value, will be equal to 2.558. So I'm going to take the half of this here and half of this here. It's going to be minus 1.279, and this is half of this here will be minus 1.421. When I distribute this moment at this ratio, it's going to be 0. And this moment at this ratio, when I distribute it, it's going to be 0.48. It's going to be 0.799. And when I just carry over this moment here, it's going to be 0.24. And when I carry over this here also, that's going to be 0.4. Now I'm going to distribute this moment at this ratio, and I'm going to obtain minus 0.126 minus 0.114, and I'm going to carry over here also this one, and this is going to be minus 0.063. This is going to be minus 0.057, and I'm going to distribute this moment at this ratio of 3/8 and 5/8. Of course, I'm going to take the negative sign of them. This is going to be 0.021. This is going to be 0.036, and this is 0. This is 0, 0, 0. Take the half of this here, 0.018. This is going to be, take the half of this here, 0.010. Okay. And when I distribute this load this moment at this ratio, it's going to be minus 0.005 minus 0.005. Okay. And for this one, I'm going to solve it here, and it's going to be the same for all of them. Okay. So, for example, for distribution, dA 5.4 multiplied with 10/19 multiplied with minus 1 equal to minus 2.842. Yeah, let's calculate like this. All distribution, if you want to, all carry over its moments, if you want to distribute them, you are going to multiply with its own distribution factor and multiply with minus 1. And now if I came to close to 0, if it's close to 0, you can stop. It's okay. So let's calculate the summation of the moment. Okay. The summation of the moment will be calculated from the fixed end moment until the last row of distribution. So this value will be equal to, for this moment, minus 6.884 and 2.427 minus 2.427 and minus 0.835 and 0.835. Okay, and this is going to be 0.418. And now I have the moments. If I have the moments, let's find the R value. You know R, I guess you know it. It's going to be something like that. 0.2 multiplied with 18 minus AX minus BX minus R equal to 0. Okay, this R value I need to calculate it. So I'm going to find the AX and the BX value. How I'm going to find it? I know the moments, so let's find them. And for example, this is my column, and I lay it down. And I have a moment here at this direction 6884. I have a moment here 2427, and I have a force distributed, but I convert it to the point load. Okay, it's going to be a 3.6 and this is 9 feet. This is A, and this is D. I have a D, AX. Okay, I just lay it down. When it stops like that, this is AX. I just lay it down. Okay, it's just lying down. So now let's calculate it. The total moment at D is equal to 0. Total moment at D is equal to 0, and this is positive. .6 multiplied 9 plus 6.884 minus 2.427, and of course minus VA multiplied with 8. Positive. It's going to be plus, equal to 0. VA, this is going to be negative. VA will be equal to 2.048 kips. Let's do it for the other part. And for the next part will be something like that. I have a moment here as at this direction, and this is also at this direction. This will be 0.835. This is 0.418, and total moment at C is equal to 0. This is C, this is B. Okay, total moment at C equal to 0. Minus 0.835 and minus 0.418 plus VB multiplied with, this one is 12 feet. 12 equal to 0, so VB will be equal to 0.104. Chips. So now I find the shears. Okay, so let's find the R value. The R value will be this. When I take 3.6, as I'm going to now apply this equation. Okay, 3.6 minus 2.048 plus 0.104 and equal to R. What is R? R is equal to 1.65K. Now I find the R value. We assume that there is no any deflection, any displacement. So we are going to now calculate with the displacement. Now this R value will stop here, and we are going to solve the next part. Okay, let's solve it. You know this both end with fixed, so we are going to use this formulation, and for this formulation the formula will be 6EI delta over L square. Okay, let's calculate it to find the displacement, but it's going to be different because you know the shape will be like this. When it deflects, shape will be like that. Okay, this delta prime and this is delta prime also. This is going to be the same, but because of the length of columns, the fixed end moment will be different. We are going to assume one of them and we are going to find the other one. Okay, let's find it. Fixed end moment fixed end moment for BC. For example, this -10 keeps fit. Okay, this minus, it comes from here. If it is at this direction, it's negative. Okay, if it is reverse, it's positive. This is -10 kilofeet equal to -6 multiplied with EI multiplied with delta prime over L square for BC. What is L square BC? 12 square, right? Okay, now we are going to identify the delta prime. Delta prime will be equal to 240 over EI. Okay, now I have a delta prime. So if I have a delta prime, I'm going to write this formula also for AD, and I'm going to find the fixed end moment that I'm going to use for AD. So fixed end moment AD will be equal to -6 multiplied EI multiplied 240 over EI, okay, over L square. What is L? What is L? L is 18, right? 18 square. I can show you. L is this one. 18 square for AD. For CV is 12. So when I calculate for AD, one second, I'm going to take this line as better. And this will be equal to -4.444. Okay, now I have my fixed end moment. So I'm going to write its own place and with the distribution factors also. And we are going to solve the question. Let's write it. This is 0. The distribution factors, there is no any change about them. So it's going to be 10 over 19. 9 over 19, 3 over 8, 5 over 8, okay? And the fixed end moment will be -4.444 minus 4.444, okay? And for here, there will be -10. This is going to be also -10. So now let's distribute the moments. This is going to be 0 because when you take the -4.44 with the 0, it's going to be 0. This will also be 0, and this one, when I distribute it at this ratio, I'm going to obtain, for example, I'm going to write here -4.444 multiplied with 10 over 19, like that, multiplied with -1. Will be equal to 2.339. Okay, so let's write it 2.339, and it's going to be 2.105. And for this one, -10 multiplied with 3 over 8 and multiplied with -1, it's going to be 3.75, and it's going to be 6.25. And I'm going to take the half of this here and half of this here, and this both will share each other, okay? And it's going to be 1.17, and this is going to be 1.053 and 1.835, and this is also be 3.25. I take the half of this 6.25 over here, half of this one to here, half of this one to here, and half of this moment to here. Okay, the carryover, it's going to be half of them. And now I have the moments. So if I have a moments, let's distribute them. This one will be distributed at this ratio, 1.875 multiplied with 1019, 1.875 multiplied with 10 over 19 and multiplied with -1 will be equal to -0.978. Okay, -0.978. 987. Sorry, 987. Okay, and this is going to be minus 0.888, and I'm going to multiply this one with this ratio. 1/53 multiplied with 3/8 multiplied with minus 1 will be equal to minus 0.395. So minus 0.395, and this will be minus 0.658. Let's carry over them. I'm going to make a carryover here. The half of them will come here as minus 0.494, and it's going to be here. It's going to this direction. It's going to be minus 0.198, and here will be minus 0.444. Okay, when I make a carryover to this direction, minus 0.329. I'm going to text here a little faster because you understand how it's going to be. Okay. And now it's okay. Let's calculate the moment values. The moment values from fixed end moment, until the last row that we distribute or carry over. Okay, the last row. But if you stop with distribution, it's going to be better. Okay, and from fixed end moments until the last row, and we are going to calculate the moments. It's going to be minus 3.735. Okay. And this is going to be minus 3.029, 3.029, 4.1485, minus 1485, and minus 7.074. Now we have the moments, so let's find the shears. You know, we need an R prime. How it's going to be? The formula is something like this. I'm going to write here. I told you that the deflection will be like that. Okay, if you remember. So the moment will be, 1 second. The force will act here at R prime, but the AX and BX will act at this direction. Okay, so there is 2 shear, so I have to find my shears to calculate the R value. So I can write here R prime plus AX plus BX equal to 0. So now I'm going to calculate the AX and BX. Let's calculate AX. For AX, I'm going to lay it down like that, and I have a moment here as this direction, and this moment also here at this direction. 3.029. This is D. Sorry, this is B. Sorry, this is A. This is 3.72. Sorry, 735. Okay, and I have an AX here. How I'm going to find AX? AX will be equal to the summation of the both moments. When I divide it with the length of the column, I can find AX. 3.735. Okay, plus, sorry, it's going to be negative, because you know the moment here are negative. 3.029 over 18 will be equal to minus 0.376. Okay, And for also bx, we have a moment at this direction, 4.1485, and also we have another moment here at this direction, 0.74, and this is b, and this is this is c. So bx, I have here bx. I just assume this direction, okay? It's not the right direction. And I'm going to take as minus 4.1485 minus 7.74 over 12. And I'm going to obtain bx as 0.935. Now I have my ax and bx. If I have an ax and bx, so I can calculate the r prime. Okay, what was r prime? R prime minus ax, what is ax? Minus 0.376 minus bx 0.935 equal to 0. So r prime is equal to 1.311. Okay, now I determined r prime also. I determined before r, here, this is r prime. So let's find the moment that we need. Okay, the moment at AD. I am going to make calculations here. The moment at AD will be equal to the first moment of AD. Okay, what was that? Minus 6.884. Okay, plus 1.656, the first r, over r prime 1.311 multiplied with minus the second moment of AD minus 3.775 will be equal to 11.6 Gibbs feet. Okay, of course it's going to be minus. Moment dA will be equal to 2.427 plus 1656 over 1311 multiplied with the second moment of dA minus 3.029, okay, will be equal to minus 1.4 Gibbs feet. And for moment DC, minus 2.427 plus 1656 over 1311 multiplied with 3.029, the second moment of DC, and it's going to be 1.4 Gibbs feet. And for moment CD, minus 0.835 multiplied with 1656 over 1311 multiplied with 4.149 equal to 4.41 Gibbs feet. And for moment DC, for moment CB, for moment CB, 0.835 is going to be plus 1656 over 1311 multiplied with minus 4.149 minus 41 kilo feet. So Gibbs feet. It's because of the kilonewton I just confused. Moment BC equal to 0.418 plus 1.656 over 1.311 multiplied with minus 7.074 equal to minus 8.52 gives fit. Now we find the moments. These are the results. Thank you for watching. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. Thank you for watching me. See you for the next question.